But first, you'll need to know what a coupling is, why couplings are used, where they are used, and how they work. Generally, machines that can produce power are made separately from machines that use power to do some form of work. Machines that produce power are called drivers. Examples would include electric motors, turbines, and gasoline engines. Machines that use power to do some form of work are called driven equipment. Driven equipment would include pumps, compressors, and fans. In the case of rotating equipment, some device is needed to connect the shaft of the driver to the shaft of the driven equipment. This device is a coupling. In short, we have a machine that produces power and another machine that uses power to perform useful work. The two are connected with a coupling. Let's look at some examples of couplings in common use. This coupling joins a turbine to a gear reducer. The gear reducer then decreases the RPM of the drive shaft before transferring power to another piece of equipment. Our second example connects the driver, a steam turbine, to the driven equipment, a centrifugal compressor. The turbine supplies the power. The compressor uses the power to compress a gas. The two are linked by the coupling. Another example of a coupling is shown here. This coupling couples the electric drive motor to the reduction gearbox. As you can see, couplings are used in a wide variety of situations to couple or connect two separate shafts or machines. As we mentioned earlier, couplings are used to accomplish two basic objectives: to connect a drive and driven shaft, and to transmit power between the shafts. However, couplings are also used for other purposes. One class of couplings is designed to compensate for minor misalignment between the rotating coupled shafts. We are referring only to minor misalignment, not major problems. Certain couplings are designed to permit a small amount of axial movement of the shaft during operation. There are also special couplings that are designed to absorb and cushion power surges between the driver and the driven equipment. These advantages and disadvantages of certain types of couplings are taken into account when selecting a coupling for a specific application. In short, the needs are determined, and a coupling is selected to meet those needs. We'll tell you more about these basic types of couplings after you complete exercise number 1 in your workbook. There are two basic classifications of couplings that we will deal with in this course. They are the rigid and flexible classes. The rigid couplings are the simpler of the two classes. They are generally used in applications where transmitting power from one machine to another is the only concern. In other words, they are only expected to lock two shafts together, making them operate as a single shaft. The flexible couplings are also used to transmit power from one machine to another, but they are also designed to fulfill other requirements. The requirements could be to correct misalignments, compensate for axial movement, and cushion power surges. The coupling design will determine whether or not lubrication is required for the operation. If the coupling has metal parts that will rub against each other, causing friction, then lubrication will be required. We mentioned a moment ago that we would deal with two basic classes of couplings, the rigid and the flexible. Needless to say, there is a tremendously wide variety of types in each of these classes. In fact, there are so many that we will only attempt to cover the basic types in this training module. We will deal with two types of rigid couplings and three types of flexible couplings. You will find that these 5 examples are very common throughout industry. Therefore, you should be able to apply the information you learn here to the other couplings you will come in contact with. Our first 2 types of couplings are in the rigid class. They are the split sleeve and solid flange types. Neither of these types of couplings will bend or give. They are designed to solidly connect the drive and the driven shafts, making them in effect a single shaft. Because of the solid connection of a rigid coupling, it does not offer very many advantages. It will not compensate for misalignment of the shafts or for axial movement of the shaft, and it will not cushion power surges. This is true of both the sleeve and the flange coupling because of their rigid construction. They are not flexible and will not give or absorb misalignment or any type of shock. The one advantage of the 2 rigid couplings is that neither of them require lubrication, since there are no moving parts to create friction. Once again, the 2 types of rigid couplings are the split sleeve and the solid flange. As you well know, there are other types of rigid couplings, but these are the 2 of the more common types now in everyday use. Our second class of couplings is flexible, and as we mentioned earlier, we will cover 3 types of flexible couplings: the gear, grid, and disc. All of these couplings are more complex than the rigid couplings you saw a moment ago. We'll show you each of them and explain some of their advantages and disadvantages. This is a gear coupling. It does require lubrication, since there is metal-to-metal contact between the gear teeth on the hubs and the teeth in the bells. However, it does compensate for minor misalignment and for some axial movement of the shaft. A disadvantage is that this type of coupling will not cushion power surges or shock. This is a grid coupling. It does require lubrication since, as with the gear coupling, there is metal-to-metal contact between this grid and the slots in the hubs. However, the spring steel of the grid in this coupling adds up a number of advantages. A big advantage is that the grid coupling smooths out sudden or abrupt power surges through the spring action of the steel grid. The grid also allows the coupling to compensate for minor misalignment and for some axial movement of the shaft. All in all, the grid coupling is very useful in a wide variety of applications. The third type of flexible coupling that we will cover in this training module is the disc coupling. This coupling does not require any lubrication whatsoever, since there is no real metal-to-metal friction. The advantages of this type of coupling are built into this shim pack, or disc, as it is called. This pack of thin, flexible metal plates allows the coupling to move in various directions without seriously affecting its operation. For instance, the disc coupling will cushion light power surges, will compensate for minor misalignment, and will allow a small degree of axial movement of the shaft. Once you get your hands on one of these disc couplings, you'll understand exactly why it works as it does. The disc is generally considered the most complicated of the 5 basic types we have shown you here in the last few minutes, but it has the most advantages, too. As with the rigid couplings, there is an endless variety of flexible couplings on the market. However, you'll find that most of them are variations of the basic types of couplings you see here. Don't forget, there are 2 basic classes, rigid and flexible. The 2 basic rigid couplings we will concentrate on are the sleeve and the solid flange. The 3 basic types of flexible couplings we will work with are the gear, grid, and disc couplings. We'll be back to tell you more about rigid couplings after you complete exercise 2 in your workbook. This segment of our course deals with rigid couplings. We'll explain how each of the couplings works and show you each of the parts and familiarize you with the nomenclature. As we mentioned in the last segment, we will deal only with 2 basic types of rigid couplings, the sleeve and the flange. First, let's look at the split sleeve. As you can see, it is made up of 2 halves which are bolted around the shafts to be connected. Let's remove one of the coupling halves from the shafts now and show you how the coupling works. As you can see, there is a keyway in the coupling half and in the shaft. This key then prevents the 2 shafts from turning within the coupling. There are also 2 other positioning grooves that resemble keyways around the inside circumference of the coupling. Positioning rings, like these on the shafts, fit into the grooves and prevent the shaft from moving in or out of the coupling during operation. The positioning rings could be half rings like these that fit in grooves in both the shaft and the coupling. Remember, the keyway along the length of the sleeve coupling prevents the shafts from slipping or turning inside the sleeve. The positioning rings and grooves here prevent the shafts from sliding in or out of the coupling during the operation. The other type of rigid coupling we want you to become familiar with is probably the most basic type. This is a flange coupling. It is very simply constructed and quite easy to understand. These are the hubs of the couplings. And these are the flanges. The coupling halves are installed on both shafts to be connected. There is also a key that fits in the keyways of both the shaft and the coupling hub. The key prevents the coupling hub from twisting or turning on the shaft during the operation of the machine. The key may be held in place by a set screw or some other locking device. Once the coupling halves are properly installed on the shafts, the flanges are then securely bolted together. We'll show you more on the installation procedures for both of these couplings in the next segment of this course. Remember, both the split sleeve and the flange couplings are the rigid class. They cannot be used to correct misalignment. They will not absorb power surges or shock, and they will not compensate for axial movement of the shaft. On the other hand, Neither of these rigid couplings requires any kind of lubrication. They are simply used to connect two shafts solidly, making the shafts, in effect, one shaft. We have some questions for you now on sleeve and flange couplings. You'll find them in exercise number 3 of your workbook.